Good morning everyone. Today I would like to discuss a problem on Gauss Divergence Theorem. First of all, what is the statement of the Gauss Divergence Theorem? The Gauss Divergence Theorem is relating with the surface integral and volume integral. We have the idea the relation of surface and volume means volume integral of div f dv is equal to surface integral of f dot m ds. In this, f vector is a given vector that is continuously differentiable vector point function, and n vector is the outward drawn normal vector at any point of the given surface. Okay, I am taking one problem and find out the relation and prove that the Gauss divergence theorem verification. Okay, verify Gauss divergence theorem for f bar is equal to x cube minus yz into I minus 2x square y into j plus zk taken over the surface of the cube surface of the cube bounded by the planes bounded by the planes x equal to y equal to z equal to a and coordinate planes and coordinate planes. Solution. First we can draw the diagram. Here it is a surface of the cube bounded by the planes. Okay. Here we are taking three axes. It is x-axis, it is y-axis, it is z-axis. Okay. Draw the cube. This is the length of A, it is the length of A, it is the length of A. We draw the cube. First write a square, next we draw the another square and joining of these endpoints, that is the vertices. Okay. Here this length is A and this length is A, its length is A. On x-axis let the points are A, B, C. A point is A comma 0 comma 0, B is 0 comma A comma 0, C is 0 0 A. Okay, it is in xz plane and we are taking this P Q R S. We are taking P Q R S remaining vertices. P is means this is in 3 dimension, that is in x y z plane. So the point P is equal to A comma A comma A, but S is in x y surface, so x and y values are A, z is 0. Q is in xz plane, so x and z coordinates are A, y is 0. R is in yz coordinate, so x is 0, y coordinate, z coordinates are A. If you draw and you have the idea about the points, assigning the points, then you can easy to get the verification of the Gauss divergence theorem. Here I am writing individually. A point vertices are A comma 0 0, B is 0, A, 0. Why? Because it is cube. C is, this is the O, that is the origin. O is O, 0, 0, 0. C is 0, 0, A. P is A, comma, A, comma, A. Q is 0, it is in XZ, A, comma, 0, comma, A. R is in YZ, 0, A, A. S is A, A, 0. Okay. Here the surfaces are one is OASB, that is in XY plane, OASB. Another one is OBRC, OBRC. Third one OAQC, OAQC. These three are over. The top are BRPS, 6 faces, BRPS, stop over. The front surface is PQCR, PQCR. This side, that side. Remaining is 6th surface, ASPQ and ASPQ. Total cube has 6 faces. Okay, 6 faces, 8 vertices. By using of these, we can find out the verification of the Gauss Divergence Theorem. By Gauss Divergence Theorem, we can prove that volume integral div f dv is equal to surface integral f bar dot n bar ds. We can prove this LHS equal to RHS. First of all, we are taking LHS. LHS is the volume integral div f bar dv. Here V is the volume. In this case, div f bar is equal to del dot f bar, that is equal to I dou by dou x plus j dou by dou y plus k dou by dou z dot f bar is x cube minus yz into I minus 2x square yj plus zk. Dot product in between of these two vectors, then that is equal to dou by dou x of x cube minus yz plus dou by dou y of minus 2x square y plus dou by dou z of z. It is equal to x cube derivative partial differentiation is 3x square, yz with respect to x it is 0 minus 2 2s are 4, 4 sorry, x square is a constant, that is 2x square, z derivative is 1. Okay, it is equal to x square plus 1 minus 2x square, here this is 3x square. The del dot f is equal to del dot f, that is equal to div f bar is equal to x square plus 1. Okay, next to find out the volume integral V div f dv is equal to integral coordinate limits 0 to a 0 to a 0 to a. Div f is x square plus 1 into dv is dx dy dz. It is equal to integral, it is x equal to, it is z, it is yx, if you can take any order, integral 0 to a 0 to a. Now I am integrating with respect to x square differentiation is integration is x cube by 3 plus x into dy dz limits from 0 to a. It is equal to integral 0 to a integral 0 to a cube by 3 plus a into dy dz. It is equal to integral 0 to a cube by 3 plus a is a constant, dy integration is y from 0 to a. It is equal to a cube integral 0 to a cube by 3 plus a into a minus 0 into dz. That is equal to a power 4 by 3 plus a square. Again integral of dz is z from 0 to a, that is equal to a power 4 by 3 plus a square into a minus 0. It is equal to that is div f dv integral volume integral is equal to a power 4 by 3 plus a square into a, that is a power 5 by 3 plus a cube. It is the LHS. Let it be equation 1. Okay. It is only LHS over. Next we can find out the RHS for 6 faces. Okay. 6 surfaces. RPS. This O is 0 0 0, P is A is A 0 0, B is 0 A 0, C is 0 0 A, B, C. Q is A 0 A, R equal to 0 A, S equal to A 0, and faces are OASB, OBRC, OAQC, BRPS, PQCR, ASPQ. The diagram is A, B, C, P, Q, R, S. it is z. A power 5 by 3 plus a cube. And the f vector is, here f vector is x cube minus yz into I minus 2x square y into j plus zk. Okay. Now I am taking the first surface, that is OSSB. OS OASB RHS. Case 1. Take OASB surface. In this, n vector is the outward drawn normal vector along x-axis. It is a positive direction, so it is n bar equal to I, and that is in OASB is in xy plane, so ds equal to dx, it is in xy plane, and the normal vector along x-axis, the normal vector along x-axis, not along OASB, it is the xy plane, means the outward normal vector is z-axis. The z-axis means the n bar is equal to k, but it is minus k. Why? Because this is a surface is in front side, but the back outward normal vector is, that is the, along with this means it is back side, so n vector is equal to minus k vector. ds is equal to, in the xy plane, so it is dx dy. Next, O is 0 0 0, A is A 0 0, S is A 0, B is 0 A 0. In this, outward normal vector is k bar, means here z. What is the z value? Z is in all points 0, so z value is 0. From this, dz equal to 0. Okay. Now find out f bar dot n bar is equal to f vector dot n vector, means x cube minus yz into I minus 2x square yj plus zk dot k vector. Then k vector dot k vector equal to 1. Then this is equal to 0. F vector dot n vector equal to z. But the z value is 0, so it is 0. Therefore, surface integral f dot n vector ds is equal to 0. Surface integral 0 is 0. Let it be equation A. Next, case 2. We are taking the same face opposite, that is CQPR. Take CQPR surface. Here C is 0 0 A, Q is A 0 A, P is A, R is 0 A. Okay. Here, for this surface, the outward normal is, it is the surface, it is the face From this point to outward normal is z-axis. Z-axis unit vector is k. So here n bar equal to k vector and ds is equal to, it is in xy plane. So dx dy, but in this all cases z is equal to a is a fixed value, no changing. So z equal to a, then dz is equal to 0. Here the same f dot n vector is equal to, here f vector dot n vector, here n vector is minus k vector, minus here will get minus z. In this case we are getting plus z. But we know that z is equal to a, so f dot n vector is equal to a. Surface integral f bar dot n bar ds equal to, in this dx dy means x and y limits are 0 to a, 0 to a into dx dy. A is a constant right outside. Integral over s f dot n ds is equal to, a is outside. For x integration is 1 dx integration is x, 1 dy integration is y, 0 to a, 0 to a. Why? Because these two are independent, there is no variables are there, so no change. A into a minus 0, a minus 0, applying the limits, a into a, it is equal to a cube. Surface integral f dot n ds equal to a cube, it is the b equation. Second case. Third case, in this CQ PR over CQ PR over A OA SB over. Next, case 3. Take AQPS or ASPQ. Take ASPQ surface. Okay, in this A is A00, S is AA0, P is AAA, Q is also A0A. It is in YZ, the surface is in YZ plane, dy dz. But unit normal vector along x-axis, it is a positive direction because of this is a face right side. So here n vector is equal to I and x is equal to, here in the all x coordinates are same. So x equal to a, then dx equal to 0. F dot n ds, f bar dot n bar ds is equal to, here n vector is I dot I equal to 1 x cube minus yz into dx is dy dz. Here a x equal to a, substitute here a cube minus yz into dy dz, and here x and y and z limits from 0 to a. So surface integral f dot n ds is equal to y limits from 0 to a, z limits from 0 to a. F dot n ds is a cube minus yz into dy dz. It is equal to a cube, y integration is y minus, in the second term, y square by 2 z, limits from 0 to a, integral 0 to a dz. It is equal to integral 0 to a power 4 minus a square by 2 z. Upper limit is a, lower limit is 0. So lower limit terms will be 0. Next integration, that is equal to a power 4 z limits from 0 to a minus a square by 2 into z square by 2 limits from 0 to a. It is equal to a power 5 minus a square by 4. Here a square into a square, that is a power 4 by 4. It is equal to C, equation C. Next, case 4. The same opposite is OBRC. OBRC. Take OBRC surface. It is in XY plane only. Sorry, it is in YZ plane. Here ds equal to dy dz. The outward unit normal vector along opposite of x-axis, so n bar is equal to minus I, and here y and z limits from 0 to a. And here O means 0, 0, 0, B is 0, A 0, R is 0, A, C is 0, 0, C, A. Here in the x values all are 0. Here x equal to 0, in this dx equal to 0. F bar dot n bar ds is equal to dot n bar equal to f bar dot n bar is, here I is there, here minus I we are taking, that is minus of x cube minus yz, and we substitute x equal to 0 means minus into minus plus yz. Surface integral f bar dot n bar ds equal to y limits 0 to a, z limit 0 to a, f dot n vector is yz into ds is dy dz. That is equal to, for y variable integration is y square by 2, z variable integration is z square by 2, limits from 0 to a. Then 2 2s are 4, a square into a square, a to the power of 4. It is equal to D. Okay. Next. Case 5. Take OAQC. OAQC surface. OAQC surface. O is 0 0 0, A is A 0 0, Q is A 0 A, C is 0 0 A. Okay. In this, it is a down surface. The outward normal vector is opposite of y-axis, that is minus j. Here n vector is minus j. In all y coordinates are 0. So y equal to 0. Then dy equal to 0. ds is, it is in xz plane, dx dz. The limits from x and z are 0 to a. f bar dot n bar is equal to, in the y means minus 2x square y into minus j, minus into minus plus 2x square y. But here y equal to 0, so 2x square into 0, it will be 0. So surface integral f bar dot n bar ds is equal to integral 0 ds equal to 0. It is E. Next, last one. Here B is a cube. Last one, case 6. BRPS, that is BRPS. Take BRPS surface. B is 0A0, R is 0A0, R is 0AA, P is AAA, S is AA0. In this, all y values are A, then dy equal to 0. Why? Because it is in xz plane. Then ds equal to dx dz, and x and z limits from 0 to a. And unit vector, outward unit normal vector is j. So n bar is equal to j. F bar dot n bar equal to minus 2x square y. Y is equal to a, substitute 2ax square. Integral, surface integral f bar dot n bar ds equal